Hello everyone. Thank you for being here today and giving me opportunity to be a part of Day of Security conference. This is a great concept for the woman by the woman. Before we deep dive into the topic, I will briefly introduce myself. I am Shruti, a cloud security engineer at Oracle. In my 8 years of professional experience, I have worked across network security, application security, threat governance domains at organizations like Cisco and Oracle. My topic for today is API security, protecting your connected world. So now I will walk you through the agenda of this session. So we will start with some general understanding of API, its importance in modern software development, and few examples. Moving over to types of API protocol. How can we pick the right API technology based on our requirement? Then we will move to why API security is important and what are the common API security threats. Further, we'll discuss best practices for API security. Then we will move on to various stages involved in secure API development lifecycle. We will also look into real life case studies on API security related incidents. Okay, so API, what is API? An application programming interface. It allows software applications to interact with each other. APIs facilitate seamless integration between web applications and external services. It acts as a bridge and allows developers to access the data and functionality from the third parties. This empowers applications to provide interest personalized experiences. For example, a weather app retrieving real time data via API. So, we'll take an example of Google Maps. This application on a mobile device does not store all of the names of the streets, towns, cities, restaurants, movie theaters, and other landmarks in our phone. Instead, it connects to another application within the Google server that contains all of that information. So, this connection is made possible by using the API. Yeah, so in web development, picking the right API technology is like picking the perfect tool for a job. SOAP, REST API, and GraphQL are three popular approaches for implementing APIs. So we'll discuss one by one. The first is REST, which is representational state transfer. It employs HTTP request for data access and uses. These data types are get, put, post, and delete, which refers to the reading, updating, creating, and deleting of resource related actions, respectively. REST APIs are designed to be simple, scalable, and flexible. They are often used in mobile and web applications, as well as IoT and microservices architectures. REST is cache friendly and supports multiple formats, which is important when we are building public facing APIs. The flexible data formatting that we get as a result makes them extremely useful for varied applications. Next is GraphQL. So with REST API, it takes number of calls to the REST API for it to return the needed stuff. So GraphQL was invented to be the changer in this scenario. GraphQL queries access not just the properties of one resource but also smoothly follows references between them. While typical REST APIs require loading from multiple URLs, GraphQL APIs get all the data which our app needs in a single request. And apps using GraphQL can be quick, very quick, even on a slow mobile network connections. The next is SOAP. SOAP stands for Simple Object Access Protocol. It is a messaging protocol which is used for exchanging structured data between different systems over the internet. SOAP is an XML based protocol and is considered one of the earliest web service protocols. It is protocol independent, platform independent, and supports several security standards, making it very secure choice for transmitting sensitive data. Yeah, but it can be complex to implement and may require specialized expertise, but its rich security features is still irreplaceable for billing operations, booking systems, and payments. So, as the summary, we can say REST is good for simple data sources where resources are well defined, and GraphQL is good for large, complex, and interrelated data sources. While SOAP is useful in payment related applications as it is very secure. We'll move to the next slide. Why API security matters. We live in a digital era where organizations heavily rely on APIs to facilitate seamless communication and integration between systems and applications. And failure to secure APIs can have severe consequences, including financial losses, data breaches, reputational damage, and loss of customers' trust. So, by prioritizing API security and investing in the necessary resources, organizations can enhance their overall cybersecurity posture, thereby reducing the risk of breaches and build trust with their stakeholders and the customers. The loss of customers' trust, negative publicity, legal consequences, and customer churn can have long-lasting effect on an organization's bottom line and market position. The next is data privacy regulations mandates such as GDPR, HIPAA, PCI DSS, and CCPA. For example, GDPR. GDPR is General Data Protection Regulations. So, based on GDPR, businesses are only allowed to collect personal data if there is a legitimate reason for doing so, and are required to inform the data subject on how their data would be processed. Next slide is about common security threats. API holds the keys to lot of valuable information, and if not properly secured, it can potentially expose sensitive data, which is very dangerous. There are many API security risks that businesses and organizations should protect against. The first one is injection attack and cross-site scripting attack. So injection attack occur when malicious code or data is injected into an API request. This can include SQL injection, where attacker injects SQL code into the API request to gain unauthorized access to the database. While the cross-site scripting attack, here the attacker inject malicious code into the web page that is accessed through the API. The next is authentication and authorization vulnerabilities. So APIs that lack proper authentication and session management can be vulnerable to attacks where an attacker can gain unauthorized access to the API. This can include guessing or cracking passwords, stealing session cookies, and other forms of identity thefts. The next is misuse of API keys. So API keys are unique, secret strings that are provided to the authorized users and systems. If these keys are compromised, they can be used to gain unauthorized access to the API. Uh, the, the fourth is denial of service attack, DOS and DDoS. So APIs can be vulnerable to DDoS attack, where an attacker floods the API with large number of requests in order to overwhelm the server and make the API unavailable. The last one is API endpoint manipulation. This is a method of changing the request to an API. This may include a change in the base URL resource path or query parameters. Okay, so now we will look into this vulnerability in details with illustration. So let's move to the next slide. The first is broken object level authorization. So we have discussed about authorization. So attackers substitutes ID of their resources in API call With an ID name and the ID, which is very dangerous again. The next slide is broken authentication. So incorrectly implemented API authentication, it allows attackers to assume user identities. So here we can see the token has been expired and was not renewed, which allows the attackers to resume identity of legitimate users. So whatever the previous user was doing, the attacker can gain the same access using the same token. So it's very important to renew the token after a certain point of time. Excessive data exposure. So APIs exposing data which is not needed for clients, expecting the clients to do the filtering. Attackers goes directly to the API and has it all. It includes personal data like salary, account number, phone number. So all these are exposed with the API call, and any attacker can just extract this info by just looking into the API calls. The next is lack of resources and rate limiting. So in this case, attackers flood the API with huge number of requests, and since API is not ready to handle this, it goes down. So let me ask you this: can anyone guess what attack it is? Okay, let me put a poll for this. Yeah. So can you let me know what type of attack it was? So here the API is attacked with huge number of requests, and API is not ready to handle this. Okay, I got the three votes, all right. Five votes. Okay, 10 votes already. Thank you everyone for your prompt response. Okay, I'll wait for a few more seconds. Okay, I think most of the people, the majority is correct. This is DOS and DDoS attack. While I see other people has also voted for injection attack and security misconfiguration. No, it's not correct. This is the example of DOS and DDoS attack. Like we should always put the rate limiting in these cases where if we see many attackers like many requests coming at the same time, we can reduce the rate. So yeah, this is a part of DDoS and DOS attack. Let's move to the next slide. Injection. Attackers makes API calls with syntaxes or commands that the API or backend executes blindly. So see here, whatever the code which was being used before, it is manipulated and which is not recognized by the system and is used again, and it is being processed as the legitimate request. This is the same we were discussing before, the SQL injection and cross scripting injection. So this is an example of the same. We can see here this get accounts ID or one is equals to one. This code is manipulated with select from accounts where user ID or one is equals to one, means it is directly getting the account number of the users by manipulating the previous code. Okay, so moving to the next slide, security misconfigurations. So security misconfigurations include unsecure transport. Maybe people are using HTTP protocol, which is not secure at all. The next could be policy, like poor policy enforcement, unpatched systems, and verbose error messages. So these are the types of security misconfigurations. The next is insufficient logging and monitoring. So we can see here the user is Sam and multiple passwords are attempted. We can see password 1, password 2, password 3. And here there is no monitoring in place, so attacker is able to make multiple attempts to crack the password. So yeah, monitoring should be in place always. So in the next slide, we'll discuss about the best practices for API security. We saw the threats and the breaches, what could happen, but what could we do to secure it? So let's move to the next slide. The best practices for API security. So there are few measures we can take on our end to secure the API. The first one is implement authentication and authorization. So the first line of defense against unauthorized access is to implement an authentication system that requires users to provide valid credentials before they can access any data. In the same way, authorization is also important as it dictates what level of access each user has to for the specific information. So for these, we can enable two-factor authentication, 2FA, to provide an extra layer of security. And few examples for these are API keys. We can use the keys, OAuth. We can use JSON Web Token. So these are the measures we can take for the authentication and authorization. The next is use of HTTPS or TLS encryption. So all communications between APIs and clients should be secured through an SSL connection or TLS encryption protocols like HTTPS. So HTTPS or TLS ensures that all data sent over the wire is encrypted and kept safe from the malicious third parties. Moving to the next, which is access control. Restrict access to the sensitive data. We can restrict access to the sensitive data such as banking information or health record. This can be done through authorization policies or by encrypting the data before it is transmitted over the network. We can evaluate different methods such as authorization policies, encryption, tokenization, etc., and use whichever works best for our application needs. The next is rate limiting and throttling. We should implement rate limiting on our API calls. This will ensure that requests are promptly processed and no user can overwhelm the system with too many requests at once. Then monitoring and logging. We can set up a system to monitor user behavior and alert us if suspicious activity is detected, such as multiple failed attempts to access a certain endpoint. This will help us detect and stop malicious activities before they become a bigger issue. Update regularly and patch vulnerabilities quickly. Yes, so we need to make sure to keep our APIs up to date with the latest security patches, as well as features or any bug fixes which may have released. So this can again prevent attackers from exploiting any known vulnerabilities. We can use the API gateways, which acts as the gatekeeper between the client and the server, and the same way protecting against malicious attacks before they reach their destination. We can also use WAF, which is Web Application Firewall. So it's a piece of security software that sits between our API and the internet, filtering out any malicious traffic before it reaches our server. So it's a great way to protect against DDoS attacks and other malicious activities. All right, so these are related to the API security best practices. We'll move over to the secure API development life cycle. So for this, there are different opinions about the actual part of an API lifecycle. However, we will discuss like we are putting five classic phases, which are planning, development, testing, deployment, and retirement. So API development needs excellent planning, coding, and testing skills, along with the discipline needed to minimize customer-facing API changes. The development lifecycle should focus on building a secure and stable API. Same way, planning and design of an API should result in clear understanding of how the security features work and what is expected out of them. One more phase, like testing, is one of the most important phase because each iteration should be tested for the functionality, performance, acceptance, and security. And we need to be very sincere in the testing phase before putting the API into the production environment. Yes. So now we'll move over to the case studies. Like so far, we have seen the technical aspect of API security and how to prevent any API related attacks. But yeah, even with this knowledge in place, there are many, in real life, we have seen many scenarios where the attackers has exploited the company or the life case studies. So the first and like the most famous one is the Equifax data breach. So this the Equifax data breach has occurred between May to July 2017 at the American Credit Bureau Equifax, and it potentially affected around 143 million people, which is more than 40% of the population of United States. And in this attack, the names, addresses, date of birth, social security numbers, and driving license numbers were exposed. And there was small subset of the records which included credit card numbers also. Yeah, so this is the impact. But what lessons would we learn from this incident? The first one is no application or resource is invulnerable. So Equifax was breached because it failed to patch a small basic vulnerability was not patched, and huge amount of data was exfiltrated unnoticed because someone neglected to renew a security certificate. And the second is one, the attackers were inside the perimeter. Like we have seen the time, right, from May to July 2017, and nobody noticed. And attackers were inside the perimeter. They were able to move from machine to machine and database to database. And if they had been restricted to a single machine, the damage would have been much less. The third lesson which we can learn from this is the Equifax databases could have been stringier in giving up their contents. For instance, user should only be given access to database content on a need to know basis. I mean, giving general access to any trusted users means that an attacker can access the database anytime one more lessons which we learned is like system needs to keep an eye out for the weird behavior. So in this case, in this incident, the attackers executed up to 9,000 database queries very rapidly, which should have been a red flag. So there were multiple myths. Even though it looks very small, it can cause a huge impact on our life. So there are other security breach incidents also. So the major one in recent times are Facebook Cambridge Analytica scandal 2018 and mobile banking in Russia 2021. So in 2021, the Central Bank of Russia warned companies about an ongoing scam where attackers make use of mobile banking applications to steal information of users and utilize it to make transactions. The attackers debug the banking apps, which then enables them to research the payment order, which was done before, and architecture of remote banking API calls. And once attackers know the user's account number, they can create an order for the transfer of funds, stating the victim as the sender. So this has led to money being taken from the victim's account. Currently, the scheme has only been used to steal the money from individuals' account, and no businesses have fallen victim. The third one, which is Facebook Cambridge Analytica scandal, a data analytics firm exploited the personal information of millions of Facebook users without their consent. And the firm accessed this data through a third party app that collected information exposing a total of 87 million users' data. Yeah, so these are the major incident which has happened in the past. I have list of many, but yeah, due to time limit, we can only discuss few of this. So they say experience is the best teacher. Well, they never said it has to be our own experience. We can always learn from others' mistake and make sure we don't repeat it. All right, so that's all from my side. You can shoot with your questions. I would be happy to answer. Okay, I'll quickly go to the charts. Okay, if there is no question, thank you everyone for attending the session. It was a great exposure for me. And if you have any questions, feel free to connect with me on LinkedIn and I'll respond there. Thank you, Day of Security. Thank you everyone again.